In this example, you're asked to find the standard matrix for a transformation that reflects vectors across the y-axis and then rotates them pi over 2 radians. So to write the standard matrix for a transformation, we just need to find the transformed vector t of e1 and the transformed vector t of e2. Now this is where e1 is the vector, in this case we're in R2, so it's the vector 1, 0. Two-dimensional vector with a 1 in the first position, because of the e1 there. So to picture what happens with t of e1, we can draw this on a, just imagine that we graph this thing. So e1 would be this vector that points to the point 1, 0. So let's say that's right here. So this is the vector e1. If you, let's see, reflect it across the y-axis, so that would reflect back to here. And then from here, rotate counterclockwise. So rotate pi over 2 radians in the positive direction, which is counterclockwise this way. So that our final vector is here. So the transformed vector t of e1 would be, this now points to the point 0, -1. So this will become the first column of our standard matrix A. Now to find the second column, well, I could start to build A over here. So we have 0, -1 for our t of e1. So now we need to, for the second column, find the transformed vector t of e2. And so we're working in R2, so e2 is the vector with a 1 in the second position and zeros everywhere else. So if we graph that, so initially e2 would be this vector here that points to the point 0, 1. Now, with the transformation, you're supposed to reflect that across the y-axis. Since this is on the y-axis, that reflection doesn't do anything. But from there, rotate counterclockwise pi over 2 radians. So when you rotate, it'll land here. So this is t of e2 here. And this would be the vector, let's see, it points to the point -1, 0. That would be the vector -1, 0. And that is our second column. So that now this right here is the standard matrix for that given transformation.